Right, so in the previous video, we have learned how to integrate the expression with the with a fraction with the pattern of f prime x over fx. So for this video, we are going to discuss more some application question about this integration technique. Right. Okay, so we will discuss example 15 and also 16 in our notes. All right, so again, to answer all the question here, the application questions, of course, you need to apply a lot of concepts that you learned in the previous chapters, like trigo, all the identities of the trigonometry, and then maybe you need to have some idea on how to solve the equation that involve long, logarithm, and etc. All right, so you need to do the revision for the past chapters from time to time so that you can answer all these type of questions here. Okay, so let's start with example 15. All right, so for example 15, first part, they want to prove the identity. Okay, so this chapter generally, this question generally involve the identity for trigo in chapter 3 that we learned before. Okay, so if you want, you can pause the video first and then you can attempt all the questions. And if you cannot get an answer, only you come back to have a look how to get the answer here in details. All right. Okay, so for first part, I will start from the left hand side because for left hand side, I can see that there are two terms here. First term and the second term. It is easier to combine two terms become one. All right, rather than you want to split one term become two terms. Okay, so I will start from the left hand side. Okay, so to start from the left hand side, I'm having cotangent x. Okay, so minus cotangent 2x. So to combine them, I need to have a fraction. So cotangent is actually cos over sine. Okay, so the same thing happened here. Cotangent 2x, I'm having cos 2x over sine 2x. So I think this is very easy because of cotangent is equals to 1 over tangent, which is cos over sine. All right, then since I'm having two different fractions here, I can combine them become one fraction. So when I combine them become one fraction, I need to do the cross multiplication here. So I'm having cos x multiplied with sine 2x minus sine x cos 2x. Right? Okay, so how can we continue from here is, maybe you can have a look for your answer on the right hand side. What is the cosecant 2x? So cosecant 2x, if right in the fraction form, it will be 1 over sine 2x. So you can see that the sine 2x is in the answer, your final answer here. So for me, in my step, I will keep this sine 2x. All right, but for the rest of the thing, I will want to replace them and try to simplify them become 1. Okay, so how can we do that is maybe you can try and think how to apply some other identity here. Okay, so for denominator, I'm not going to touch it now. So I will just keep it as sine 2x. So maybe for all the terms on top, I will try to rephrase it, or maybe I will try to expand it. So sine 2x, I will expand it become 2 sine x cos x. Sine x, I will just keep it. For cos 2x, maybe I will try to expand it become 2 cos square x minus 1. Alright, so all these are from the identity of the trigo in chapter 3. Okay, so maybe I just want to want you all to recall back sine 2x, that's the identity, which is 2 sine x cos x. Okay, and then for cos 2x, there are 3 formulas that you can apply here. The first of them is this. Okay, or 2 cos square x minus 1, or 1 minus 2 sine square x. So if you are not so sure about all the identity, you can always refer back to your chapter 3. Alright, so you have to always try to learn how to apply, how to memorize them so that you know how to apply it in your solution. Okay, so when I try to combine everything here, for this I'm having 2 sine x cos square x minus 2 sine x cos square x, then minus sine x divided by sine x here and sine 2x. Okay, sorry, I think I made a mistake here. This one should be a plus sign, right? So negative sine x multiplied negative 1, you should get plus sine x. All right, so if you continue from here, and you will see that you actually can cancel off these two because they are the same. And therefore, you are having sine x divided by sine x, sine 2x. And after that, simplify the sine x, you have 1 over sine 2x. And you will see that on our right hand side actually is shown. Alright, so if you have any steps that is not so sure, please refer back to the chapter 3 and learn how should you apply all the correct identity here. Alright, okay, so this is what we have for part number 1. Okay, so let's continue to part number 2. So after you prove this identity, when you go back to part number 2, what do we have? They want you to show that, okay, for this integration, you will get 1 over 2 ln 2. Okay, so maybe we can start now. Alright, so for the second part, they want you to do the integration and the final answer that you get should be what they shown. Alright, so pi over 4, pi over 6, cotangent x. Okay, so I think I told you before in the previous example. So cotangent x, you can actually change it become a fraction, right? Which is cos x over sine x. Okay, so when you look at the cos x over sine x, you can suspect that it is actually f prime x over fx pattern. Then you can double check by yourself. So if let's say fx is sine x, so f prime x means cos x. So very obvious, you can see that the numerator on top is f prime x. Alright, so this is exactly the f prime x over fx pattern. Therefore, you can do the integration straight away where you will get ln fx. So what is ln fx? You are having ln sine x. Okay, and you want to put in the value, the limit of pi over 4 and also pi over 6 here. Alright, so if you continue from here, you will want to put in the value for pi over 4. Okay, so ln sine pi over 4, which is 45 degree, okay, minus ln sine pi over 6, which is 30 degree. Okay, so from here, if you substitute the value in sine pi over 4, you can get square root 2 over 2 if you want, or you might 1 over square root 2, up to you. Alright, so you can use a triangle to help you how to get the value for sine pi over 4. Okay, so for sine 45 degree, you should have pi square root 2 over 2 minus, for this one, you might have, you may have ln half. Ln sine half, sine 30 degrees is a half, right? So ln half. Okay, so all this, if you need, if you don't have the calculator, the ES calculator, then you can use a triangle to help you. Alright, so here you should apply some basic property about the ln, the logarithmic function. So when you're having ln A minus ln B, when you want to combine them together, it will become ln A divided by B. So ln A divided by B, when you expand it, it will become A minus ln B. So we are doing the reverse way. Alright, so if you use calculator to simplify this, you have ln half, ln square root 2. And ln square root 2, you can rewrite it become ln 2 power half. And after that, if you try to pull the power in front, then you will get half ln. And this is what they want you to show. Alright, so you can see that for these two examples here, the part 1 and part 2, right, you actually need to involve a lot of knowledge that you learned before, like the property of ln, like how you get the answer for sine pi over 4 and sine pi over 6 in the exact form. Okay, so you might need a triangle to help you and so on. So you can see that all the knowledge you learned before are linked together now. Alright, so if you forget some part of it, then you just take some time to go and do some simple revision in that particular part. Alright, okay, then after that, we continue to part number 3. So for part number 3, they want you to find the exact value. So again, I will want you to highlight the word exact value. Exact means that your final answer should be in a fraction form. It cannot be in decimal. Alright, so give your answer in the form of A ln B. Okay, so they want you to integrate the cosecant 2x. Alright, so I think I told you before, right? usually in the A-level style question, in the first part, if they ask you to prove something, usually you will need to use the result in the proving part and apply it in your solution. So this is where we want to apply it now. Okay, so let us start. They want you to do the integration for pi over 4 pi over 6 cosecant 2. Okay, so let us start. Right, so I will spare some space here. Alright, so maybe you can start with part number 3. Okay, so I'll write part number 3 here. Okay, so they want you to integrate this. Integrate pi over 4, pi over 6, cosecant 2x. Alright, so for cosecant 2x, if you make it into a fraction form, it will be 1 over sine 2x, where we never learned how to integrate this example or this kind of question before. So, alright, so since we already proved the result in first part, so I will want to apply the result in the first part here. So what is the cosecant 2x? So cosecant 2x, you can rewrite it to the left-hand side expression, which is cotangent x minus cotangent 2x. Alright, so this is the result from first part, from part 1. Okay, so this is the left-hand side. Okay, you are changing it into the, right-hand side, you change into the left-hand side expression. Alright, so this is from part 1. Okay, then if you separate it into 2 different integration, so you should have integrate cotangent x minus the integration of cotangent 2x. Okay, so this part is the answer that you proved just now in second part, part number 2. Alright, so you don't need to go through the integration anymore. You can straight away apply the, so you should have half ln 2. Okay, so for this one, it is from part number 2. From here to here, it is from part 2. Alright, then for this second part here, I will want to apply the integration again. Okay, so cotangent 2x, if I rewrite it, I will have cos 2x divided by sine 2x. Okay, then again, it is a fraction, and then maybe according to experience, you should know that it is belongs to f prime x over fx pattern as well. So if you look at the fx, it should be sine 2x. Then when you want to do the differentiation for sine 2x, differentiate sine, you'll get cos 2x, and then you need to differentiate the angle inside again. So in differentiate 2x, you get a 2. So you put a 2 in front. So your f prime x should be 2 cos 2x. And you realize that your numerator has the cos 2x already. You lack of a 2 in front. Therefore, I will need to do some small adjustment before I can do the integration. Alright, so I have half. If I continue, I will have half ln 2 minus. Alright, so I want to have the f prime x on top. Therefore, I need to do the adjustment. I will need to multiply the 2 so that I will get 2 cos 2x. Alright, so if you look at this one, then you already have the f prime x over fx pattern already. Okay, so since you do the adjustment here, you multiply 2 inside. Therefore, outside to make it balance, you have to divide it by 2 also. Alright, so from here, very obvious, you can see that this is f prime x, fx, and this is the f prime x on top. So you can apply the integration straight away. So you're having half ln 2 minus half. And now, after you do the integration, you have ln fx, which is ln sine 2x. And pi over 4 here, and also pi over 6. Okay, alright, so if you continue from here, then it shouldn't be any big problem for you. You just need some time to figure out how to get the correct answer. So, ln sine 2x, you have ln sine pi over 2, which is 90 degree, minus ln sine 60 degree pi over 3. Alright, so I will want you to try to simplify all the terms here and try to get 1 over 4 ln 3. It shouldn't be any problem for you to get this one. If you really cannot, please refer back to all the properties for ln and log in chapter number 2. Alright, so I'm not going to show you in detail here because it is quite similar to what I showed you in second part. So I want you to take this time to figure out all this yourself. Alright, so your final should be 1 over 4 1 over 4 ln 3. Okay, so this is how we apply the integration technique that you learned in the previous video. Right, so we will continue to the next one. Alright, so the next example, example 16. Okay, so they give you a figure here and then they tell that the equation is y equals to x over x squared plus 1. M is the maximum point. Alright, so there's a shaded region R from 0 until P. Okay, so first question here, they want you to find the area of R in terms of P. So they're asking you to find the area. Alright, so if you want to find the area, generally what you can do here is you need to do integration now, of course, right? Okay, so you need to do integration. So maybe I make some adjustment first. Okay, so please wait for a while. Alright. Okay, so if you want to get the area, of course, you need to apply integration. Okay, so how to write out the correct formula for area? So first of all, if you look at the area, the shaded area here, it is mainly covered by the x-axis, right? So I actually should know that I should do the integration to dx. Okay, and then it is covered by this curve. So what's the formula for this curve? So you know that this formula is equation of y, which is x over x squared plus 1. And then what is the limit? So the limit starts from here. The area starts from here, which is x equals to 0, and then until this line. So this line is x equals to p. So you're integrating it from 0 until p. Okay, and then since this is a fraction, therefore you can double check. If let's say my fraction, the fx is x squared plus 1, therefore when you f prime x, you should have 2x. Alright, so according to this example here, you should actually do some adjustment. So you need to multiply in a 2 to get the f prime x. Therefore, outside you need to divide it by 2 as well. Alright, so if you continue from here, okay, to get the integration, then you will be able to get half, you just copy. Okay, integrate the f prime x over fx pattern, you will have ln square plus 1, ln fx. Then you need to substitute in the value for p and also 0. Okay, so when you try to substitute in the value, you have ln p squared plus 1. Okay, then minus ln 1. You substitute 0 into the x squared, you get a ln 1 only. So ln 1 itself is a 0. Right, so eventually you have half ln p squared plus 1. And this is the area in terms of p. That's it. So R in terms of P. So your final answer for area is half ln P squared plus 1. Okay, so this is how we do it. Alright, how about for part number 3? So here now they want you to calculate the value of P when the area is 1. Okay, so this is quite simple. And they want you to give an answer into 3 significant figures. Alright, so now they tell you that area is equals to 1, which means that you should have half ln p squared plus 1 is equals to 1 as well. So again, now you need to apply the property for all the ln, how to solve the ln equations. Okay, I will want to bring everything over. So the 2, when I bring it over, I'm having ln p squared plus 1 equals to 2. And if I want to bring the ln over, I will have e power 2. So if you forget all this detail again, please go back to do some revision on chapter 2, the log function. Okay, then continue further. P equals to e squared minus 1. And then P, you should have plus minus sign, plus minus square root e squared minus 1. So by pressing the calculator, you double check what is the correct final answer. So from the graph here, you can see very clearly that the P should be a positive value. Then if you didn't do any careless mistake, your final answer for P should be 2.53. Alright, so these are the two examples about the application for f prime x over fx integrate here. Then, of course, if you want to get all the concept more familiar and everything, you have to try more passive questions. Alright, so these are the two examples that I can show you here for the application of f prime x over fx. Right, so I'll stop here for this video.